Hello students, as I mentioned in the ending of the last session, I will be discussing about uniform rectilinear motion. This part is going to be broadly classified into two parts, that is uniform rectilinear motion, wherein there is no external force acting on the object and therefore it moves uniformly. In that case, how does the velocity vary with time? How does the displacement vary with time? Those are the kinds of from the graphs as well as from differential equations we'll be getting the relations. Also, we'll be talking about uniform rectilinear accelerated motion. That means that there is an acceleration, but the acceleration is constant. Acceleration does not change with time. That is, there is no variable force acting on the particle. So let's try to understand more on it. So please be tuned in. So when we talk about uniform rectilinear motion, uniform rectilinear motion is the one which is basically the uniform motion. In that case, the acceleration is going to be 0. So when the acceleration is equals to 0, in that case, we can simply say that dx by dt is equals to 0. So dx by dt is dx by dt is constant, So therefore, if I just do this, so I can simply write down dx as equals to v into dt. So this is how that displacement varies. And so now if we integrate this, so if I integrate this, I'll get something like this. So here I'm integrating from x0 to x, and this v being a constant can be taken out. So we'll just be integrating over dt. So the integration of dt is basically from 0 to t. So if I just do this, so I can simply write it as x minus x0 here, and here this is going to be v into t. Or I can simply say x equals to x0 plus v into t. So this in the case is for a constant value of velocity. So v is actually a constant. Please understand about that. Let's take it further and try to understand about the case of uniformly accelerated rectilinear motion. So in this case, what is going to be the difference? The difference is, in this case, the acceleration is constant. So if I write down the acceleration in a similar manner, I can write down v equals to v0, which is equals to at. So if v equals to v0 plus at, so what does that mean? In a similar way, what we can do is this: we can say dx by dt, because v can be written as equals to dx by dt, so that will be equals to v0 plus a into t. So if I just do a cross multiplication, obviously I'll get dx, which is equals to v0 plus at into dt. On integrating this, I'll get x minus x0, which is equals to v0 into t plus half at square. So this is what we get. Or I'll get that relation as equals to x equals to x0 plus v0 into t plus half at square. Going further, what we have, since we know that acceleration is this, we have already understood quite a bit of time. Let me still revisit that. We know that acceleration is equals to dv over dt. So if I just rewrite this as dv over dx into dx over dt. So dx over dt is nothing but the velocity. So this will be equals to v into dv by dx. So this is how the acceleration is going to vary. So this is what we have. So v into dv by dx, which is a constant. So if I just do a cross multiplication here, so integrating from v0 to v dv gives us this particular thing. On integrating and putting in the limits, I'll get the final velocity square minus the initial velocity square divided by 2, which is equals to a to x minus x0. So simply writing it gives me v square equals to v0 square plus 2a x minus x0.